right, class, the first thing we have to talk about from section 7.3, which is called Proving Triangles Similar, is postulate 7.1, which is called Angle-Angle Similarity postulate. If you see the letters A for angle, angle, and then this little tilde, remember we talked about this in the last section, that means similar. So if I have two triangles and they have two pairs of congruent angles, then I know that the triangles must be similar. So if I look at these examples here, I'm going to do the first one for you. The question says, are the two triangles similar and how do you know? So looking at this picture, I see that they've given me the fact that R and V are congruent angles. But because we are so smart, we also know that angle S, namely WSR and VSB, are also congruent angles because they are vertical angles. So let's write that down. Vertical angles. So I know that now I have angle-angle similarity, and triangle RSW is similar to triangle VSB. And then there's a U-try example for you to do as well. We have two other theorems that are going to help us out. The first one is called side angle side similarity, where obviously I have a side that included angle and then another side. Now think back to when we were doing congruent triangles, because this is so similar, except now I'm talking about similarity. Side angle side was one of our theorems. Same with theorem 7.2, side 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 was one of our theorems. But now what we're saying is not only can it prove triangles congruent, but we can also prove that they're simply similar triangles. So what that means is I'm not looking for congruent sides. I'm looking for sides that maintain a certain ratio. So they have a proportion to them. So I'm looking for two sides that maintain that certain ratio or proportion, and then the included angle between them must be congruent. That information is right here for you. Side, 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 I just need all three of my sides to maintain a proportion. So let's look at two examples here. My first example, I see that they've given me three side lengths. So I'm going to set up three different ratios and set them all equal to each other to see if I end up with all equivalent fractions. So I've got, let's see, 10 is my hypotenuse. It would appear it's a right triangle. In my first triangle, over 15 is my hypotenuse in my second. Then I've got 8 over 12 and 6 over 9. So if I reduce all of those down, 10 over 15 divided by 5, I get 2 over 3. If I take my second fraction and I divide everything by 4, I get 2 over 3. And if I take my third fraction and I divide by 3, I get 2 over 3. So because I end up with all these ratios being congruent or being equal, I know that I have side, side, side similarity. So I can write that. Triangles are similar by side, side, side similarity. Now we're definitely going to want to get more specific than just triangles. I actually have to put which triangles are congruent. So let me shrink this just a tad here. So instead of just putting triangles, I'm going to write the names of the triangles. So triangle, and I have to do this in a very special way. I'm going to start with S and U for my first triangle because that's the length of my hypotenuse. And in my second triangle, I'm going to start with X and W, but I need to make sure I use the right piece. So I started with S here, which is in between my longest side and my shortest side. So here on XW, I want to start with X because that's in between my longest side and my shortest side. So I have XW, and my last letter here is T, and my last letter here is V. I'm going to do another example for you. But this time I see that I've only been given these 4 side lengths, which isn't enough to make 3 ratios. But I do notice that because these triangles overlap, I have this angle right here, which is a common angle, and it just so happens to be my included angle. If I take where my 2 sides meet, it's this angle right here. So I think I'm going to be using side angle side. What I have to do is I have to make sure that these side lengths are proportional. So for my small triangle, I'm going to use 8. Oops. Darn it. Let's go back. SUTXWV. I'm going to draw that side back in there because I erased it. That was weird. Okay. So I'm going to use this piece 8 over my larger triangle is this whole length, which is 10. And I'm going to set that equal to my short side, which is 12, over my whole side, which is 15. And then if I reduce, here I can reduce by 2, and I get 4 over 5. Here I can reduce by 3, and I get 4 over 5. So I do have 2 of my sides being proportional, and remember, we had this congruent angle, which was my included angle. So I can write my similarity statement here. I have triangle KLP similar to triangle KMN by side angle side similarity. I have 2 U-try problems here for you, so go ahead and put those into your notes. I will be looking at them in class. And then we need to look at a proving problem. So I have this picture for you here. We've got our given information, and we know what we're going to prove. So I'm going to walk through this with you. First of all, we have to remember we've got a 2-column proof. So I'm going to set up my 2 columns here. Remember, on one side, I'm going to have all my statements. On the other side, I'm going to have all of my reasons. Okay, so the first thing that I'm going to do is I'm going to go ahead and I'm going to write in all of my givens. So for step 1, I have FG is congruent to GH, and JK is congruent to KL. And also one last thing is that angle F is congruent to angle J. And how do I know all of those things? Well, I know because they were given to me. And then I have to think about step 2. So looking at my picture, I see that both of these triangles are isosceles triangles because I have these 2 tick marks saying I have 2 congruent sides. And by definition, 2 congruent sides on a triangle makes it isosceles. So I'm going to write that in here. I'm going to say for step 2 that triangle FGH and triangle JKL are isosceles. And the reason I know that is by definition of isosceles. So I'm going to put that in there, and then we're going to start thinking about step number 3. So if I know that these 2 triangles are isosceles, then for step 3, I'm going to go into what I know about isosceles and their angles. So in an isosceles triangle, my base angles are congruent, which means in my first triangle, angle F is congruent to angle H, and in my second triangle, angle J is congruent to angle L. And the way I know that is base angles of an isosceles triangle are congruent. Okay, so now I need to remind you of something. We already know by a given fact that angle F is congruent to angle J. Now we have angle F congruent to H and angle J congruent to angle L. But what I need to do is I need to figure out a way to get pairs of angles within my two triangles. I know from the given that F is congruent to J, so that's one pair of congruent angles. But I somehow need to figure out how H is congruent to L. Okay, here's how we can do this. In step 4, we are going to say that angle H is congruent to angle J. And the way I know that is by the transitive property. Transitive property of congruence. So remember, F is congruent to J, but I also have that F is congruent to H. So I can cut out that middleman, the F, and I can directly link angle H and angle J. So that's what I've done in this step here. Now I also know that angle J is congruent to angle L. So I can do the same sort of step again, and I can say in step 5 that angle H is congruent to angle L. And that's again by transitive property of congruence. And then as soon as I know that H is congruent to L, I've got F congruent to J, and now I just figured out H congruent to L. So now I can say what they wanted me to prove. Triangle FGH is similar to triangle JKL, and the way I know that is by the angle similarity postulate. I want you to go through and try your best on this proof. So they've given you the fact that line MP here, this segment MP, and AC are parallel. So what I need you to be thinking are, what pieces of information do I know about parallel lines and transversals? You're aiming to prove that this triangle ABC is congruent to, similar to PBM. I will be checking this in class, and it is very, very important that you do this problem, because without this problem, you will not be receiving points for the video. You cannot just simply skip through this you try and expect to receive the points. I need you working through this problem. The last thing we're going to do is we're going to take a look at this word problem. It's actually pretty cool. It's about this kid Darius who wants to know, how high he's going to end up climbing if he's going rock climbing. So what he does is he puts this mirror down on the ground, and then he starts walking backwards slowly until in that mirror he can see the top of the cliff. And then he wants to figure out, just by doing that, how high the cliff is. So essentially what he's done is he's created two triangles, because he's got his height, he's looking down at the mirror, which is a certain distance from him. Then that mirror is reflecting upwards to the top of the cliff, which is a certain height and a certain distance. So I have these two triangles. What I need to do is figure out, first of all, are they similar? And second of all, what's the proportion that needs to hold so I can determine what x is? Okay, so our first question is, are they similar? Well, here they tell me that I have two congruent angles, and I also have two right angles here, which means that yes, these triangles are similar by angle similarity postulate. So I have similar triangles by angle similarity, which means that my proportions of my sides are going to hold true. So 6/34, because those are my distances of my small and my large triangle, 6/34 must be equal to 5.5 over the whole height of this cliff, which is x. And then in order to solve that proportion, we're going to go through and do some cross multiplication. So 6 times x gets me 6x, and 5.5 times 34 gets me 187. then if I go ahead and if I divide by 6 on both sides, x equals 31 approximately 2. So let's change this to approximately. X is approximately 31.2. That's my answer.